Okay, so I was asked to present the Faceted Search that is working at J&J. I'll just go through a few of these, yes. So basically the idea was there, you have all these expression profiles, either gene expression or proteome expression, and we wanted to have a way to, so typically these things are, some analyst has done it, it's somewhere on a file, and we wanted to have a way to get that all together and to get access easily, flexibly, and interactively. So the idea was we want to visualize more what you are searching through, and maybe I can directly go to this. So in fact, when you have an analysis, in fact, it's part of a whole conceptual tree, where you first have a data source, you select a disease area, you have studies, subjects, specimens, samples, assays, technologies, results, and all of that stuff you would want to be able to search through. So what I did is I looked in the different terms that or concepts that we could browse, and wherever I put something in red or underline something in red, these are concepts that the Faceted Search, or in fact the Faceted Search is only a part of it. So we have about, I thought it was about 20 concepts that you can search by, and about 10 of them that we visualize in the Faceted Search. So I'll go to the or tranSMART instance. So you see here the Faceted Search, which on the home page gives you some visuals of proportions within studies and analysis. You also see here that you have a number of filters. So for instance, this filter here is one where I saved a search, and I'm just going to build that up. So I basically took as a data source the external data. I wanted to choose chronic obstructional pulmonary disease, COPD. Then I said, well, I only want analyses that expose disease versus normal, and then I wanted to look only at the genes that are related to the pathway asthma. So how I go about this is, you see I have about 300 analyses here. I take only the public ones. Then I go to the disease. So it's something related to respiratory, and I see again that you have different diseases under immunology respiratory. So I choose, and I see there are only 14 that are left. So I went to disease. There was another one that I was looking at. Let me see if I go back to the favorites. I think I lost it. So here, yes. So I took analysis disease versus normal. So here you see in the analyses, you see that there are mostly disease versus normal. There is some disease versus disease. And then I went to the pathway is not in the Faceted Search. I went to the search here where you have everything, and then I chose pathway asthma. Yeah. So that leaves me with 2, 4, 5, about 10 analyses, and in each one of these analyses I can go and look in more detail. So when I click on here for more detail, it basically shows me all the heat map. So the heat map for all of the. So you have 2 cohorts, and each, let's say, each column is a patient, and for each patient you have all the probe sets that have been probed against in your microarray, and what genes they correspond to. And you also see for each one what their fold change is. So for this gene, which I can click through and get more information on in entries gene and in CBI, I see that for this gene the fold change is 2.7 on average, and that I have a significant p-value. You see also that there are different ways of looking at this. So you see the heat map, you see also the box plot. If I go to the box plot, in fact, at this point I will see for this gene what the box plot for this gene is. So another way of visualizing this. So basically you go through the different steps in the faceted search. You look at the search results, which now, okay, and then you can walk into each of these analyses and visualize how the gene expression is based on heat maps or box plots. So I'll go to, yeah, what is also interesting is whenever you have chosen one of these things, you see that you can export data in CSV format or in PNG. Yeah, you also, if you go to the heat map, you can also see that you can export either the current page data or all the analysis data. Yeah. So that's that. Let me go back to the presentation. So what we saw is you have this search box. What I didn't show is that when you start filling in information here, it starts showing you metadata that are of interest. For instance, if I would have started typing asthma, it would show me pathway asthma, or a gene that I have. It gives me what genes I can choose. You saw that I could choose from about 20 different categories. I have here a view of what my query looks like. I can see in my faceted search how much do I have available. These filters also update and show only relevant things. And then, as we saw, we came to the result, the view of all the analyses, where we can then click through, see the heat map with an active link, only see the genes that I selected. So I selected the genes for the pathway asthma and export data of my interest. And then we had also the other view of that. Another thing that is interesting to look at, so is you have also, so I'll go back to my, I'll clear my search here and go home. You see that here too there is another type of filter that I saved. And this is about cross-trial analyses. So we can select, go again through the selection process, select a number of analyses that interest us, and then start looking at how they compare. So for instance here I selected this one. Let me try to not move the mouse. So you see that I selected a number of these analyses. Above it also says that I selected 2 genes and a pathway or a set of pathways. So I will now just select that that cross-trial analysis selection. You see that he shows me an overview, but if I now click on the gene charts, what he's showing is he's saying, okay, you selected 6 analyses, every time smoker, non-smoker to categories. And so what you see here in this view is you see the average fold change between the 2 categories, and you also see for the gene that I selected, IL-8, you see that it is significant. So the horizontal line here it is kind of the threshold between which you have a significance or non-significance. So here you see, for instance, the fold change is 1.556, as we see, and we also see that the p-value is 0.02 about. For instance, I could choose to add another gene in, and again you see here how I get a number of suggestions. I'll take the ITLN1, and you see that the ITLN1 is more significantly so involved in that separation in some way. I can also show heat maps. So what I did in my selection, I selected a number of pathways. I could also select a list of genes or a gene, yeah, so a list of genes, or you have other categories. Here I said, okay, for these 6 analyses and for the genes that are associated to the arthritis pathway, show me the heat map. So in this case, for instance, for the second analysis, we see that COPD versus non-smoker, we see that the fold change is 1.66 and that we have a p-value that is significant. So different ways of looking at things. So the combination of, on the one hand, being able to interactively search, on the other hand, save these searches, and on the other hand, visualize different things around it. So I will now go back to my presentation more and just review these things. As you saw, that's what we did. We made a selection of different analyses that we wanted to compare with one another in view of what does it mean from a specific. So you have the fold change that you see, and you also see on top of it is that distinction, is that significant for that specific gene. You also have the heat map view. Yes, I think that's a little bit of an overview. The technologies that were used, like David and Caroline mentioned, also Solar has been used for the faceted search, jQuery as a front-end UI, I use with several plugins, and then for the visualizations for heat map, boxplot, and line plot, you have this d3.js. Such conferences or workshops are ideal. I was asked a few days in front. I hadn't seen the faceted search, so I've learned this part of the capabilities. I think these are the people who are in some way associated with that function. Okay, that's